Hey guys, this is Ms. Mo. In 12.1, we're doing something called antiderivatives and these things called integrals. Integrals or integrands, the symbol looks like a little slippery snake. It's like a S. See all these slippery snakes? S, 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 S. Yeah, anyway, that's just a symbol, and that means integral or the antiderivative. Okay, so an antiderivative is just the opposite of a derivative. So if f of x is my OG equation, my original, and f prime of x is my derivative. So f of x is my OG, my original equation. My f prime of x is my derivative. We already knew that. Well, what do you think the antiderivative is? Well, if f prime is the derivative, f of x is the antiderivative. So all we're doing in this section is we're going backwards. We're looking for the OG equation, and they give us the derivative. So instead of being given the original and finding the derivative, we're going to go backwards. Yeah, okay. So let's look at these tricks. There's not much to it because there's not much to it. So first, let's just think about kind of in general. If we look at the top left of these tricks, it says f of x equals 8. And remember, f of x is the original, the OG. And then quit moving around. Okay, and then the f prime of x is the derivative. So what is the derivative of 8? Well, that's the constant, and the derivative of 8 is just 0. Okay, I don't know why my phone keeps... I have it hanging by a piece of paper, so that's probably why. Stop moving. Okay, I think I got it. Okay, so anyway, if 8 is the original, f prime of x is the derivative. And earlier we said that the OG is the antiderivative. So today we're going to be given the number 0, and we have to come up with the OG. Okay, so let's remember that the derivative of a constant like this 8 is just 0, or the derivative of -3 is 0, or the derivative of 7 is 0. Or what if we go backwards? What if you're given that the derivative is 0? What's your original equation? Well, there's not an original equation. The original equation will just be a naked number. Am I right? Because here on these 3 examples, the derivative of a constant is just 0. Well, if we go backwards and we are given the derivative of a 0, then we can say, oh, the antiderivative is just a constant, as in it's a number. So this is where the word constant comes into play. So let's go again. If the original is a constant, just a naked number, the derivative is 0. Well, there's a special symbol for the constant. So the special symbol for a constant is just C. So on your homework, if it says the integral of 0, the answer is just going to be C, as in if your derivative is 0, your original equation has a constant number in it, and that number could be anything. So C stands for a naked number or a constant. Okay, let's look at this next example. Let's take the derivative of this 8x. The derivative of 8x is just 8. The derivative of 8x plus 1, well, the 1 goes away, and then the 8x becomes just 8. The derivative of 8x plus 9, the 9 goes away, and the derivative of 8x is 8. So these 3 examples, what they have in common is the 8x, 8x, 8x. But these second 2 examples, you see that the original equation had a constant naked number on it. A constant naked number on it. So, if you are given the antiderivative, if you are given the derivative 8, and you want to go backwards and find the antiderivative, well, the antiderivative is going to be the original, and the original equation is, what did all these have in common? 8x, 8x, 8x. So definitely 8x. And then how do I represent this plus 9? It's a naked number. Or this plus 1, it's a naked number. Well, naked numbers are constants, so plus c. So if you're given that the derivative is 8, the original equation has to be 8x plus c. Because that way, when you take the derivative of 8x, it gives you the 8. And if you take the derivative of a c, it goes away. Okay, so the point of this is, if you are given that the derivative is just a number, the original is that number x plus c. Or if we look down here, it says, if you are given that the integral is 27, as in this is the derivative, then the antiderivative, or the OG equation that gives us that derivative, is 27x plus some naked number constant. Okay, or anytime you have integral of just a number, it pops out that number x plus c. Okay, so that's our second rule. Our third rule is if there's an exponent. So, let's see here. Let's take the derivative of this 5x squared. You take the 2, you bring it down, you multiply it, and you get 10x. Over here on the next one, you take the 2 in the air, you bring it down, you multiply it, and you get 8x. For this last one, you bring the 2 down and you multiply it, and you get 8x. And then that 3 goes away. Okay, so what this tells us is that whatever we start with, or if they give us the derivative, let's try and come up with a way to go backwards. So let's say you're given 10x. How do you remember that the original should be 5x squared? Well, we know this. When you take the derivative, you subtract an exponent from your x. So that's why this 4x squared becomes 8x, because when you subtract 1, you get an exponent of 1. So that's the derivative rule. You subtract 1. Well, if you want to go backwards, let's look. If I start with the derivative of 10x to the 1, and I want to go backwards to get the original, what do you have to do to this one exponent? You have to add. So if I want to go backwards, if I'm given the derivative and I have an x with an exponent, to go backwards, I take that exponent and add 1 to get the original. That's what this power rule down here says. It says if you are given an x with an exponent, the exponent in your new answer is going to be plussed by 1. So that's all it's saying. If our derivative is 8x to the 1, the original has a 2 in it because we have to add 1 to the exponent. That's what this add 1 to the exponent means. Okay, so that's where the exponent part of the formula comes from. Let's look at this big fat number, where it comes from. Let's see, if I'm trying to go backwards, how do I get from a 10 to a 5? How do I get from an 8 to a 4? Well, you're probably saying you divide by 2. That's great. But what about if my f of x was 4x to the 3 and my derivative was 12x squared? Okay, so I just asked you, how do I go backwards? If I'm given the derivative that has a 10 in it, how do I go backwards to get the original equation with a 5 in it? And you said, well, you divide by 2. Same thing on this 8x to 4x squared. You have to divide by 2. But here, what if the derivative is 12x squared? How do you get to the original 4? Do you divide by 2? No. What do you have to divide 12 by to get 4? You have to divide by 3. Where the heck does that 3 come from? It comes from your new exponent of n plus 1. So, we don't just divide by 2 when we go backwards. That only happened because my exponent was a 2. If my exponent was supposed to be a 3 in my answer, then I'm supposed to divide by 3. So that's where the bottom part of this power rules comes from. It says that you're supposed to divide by whatever your future exponent is. Okay, so what that means is, let me give you a derivative. Let's say I have, we'll just go with 12x squared. To find the original, you take x, and you raise it to the exponent plus 1. So my exponent is 2, so I'm going to raise it to the 2 plus 1. Then you're going to put it all over n plus 1. Well, that was that 2 plus 1. Okay, so we did that part of the formula. But the only thing different about this problem is I started with a number in front of the x squared. So I'm not going to look quite at this first formula because there's not a number in front of that x. Instead, I'm going to look at this second formula. And the second formula is exactly the same. The only difference is if you got a number in front of your x, you put the number in front of the x at the front on the top of the fraction. So that's the only thing different. So since I have a number in the front, 12, I'm going to put that 12 in the front at the top. And then let's see what happens. This becomes 12x to the 2 plus 1 is 3. All over 2 plus 1 is 3. And then divide that, and it becomes 4x to the 3. So this is saying that if the original equation is 4x to the 3, the derivative should be 12x to the 2. Let's check ourselves. If this is the OG equation, I take the 3 down, multiply it, and I get 12 in the derivative. And I subtract 1 from the exponent. Subtract 1 in the exponent to get 2. Yeah, okay. So, to take the antiderivative, we just go backwards. You know, when we take the derivative, we multiply our exponent with the number in front. Here, we divide. To find the derivative, we subtract 1 from the exponent. In the antiderivative, we add 1 to the exponent. Okay, the only thing I'm missing is, if we look at these two formulas, it says plus c at the back end. So when I say that my answer is 4x cubed, it's supposed to be 4x cubed plus a big fat c that you type in your homework. Okay, so let's do a bunch of examples. These won't take that long. Okay, this says evaluate integral of 5 and then dx. Okay, well, we can do this. This is just a 5, as in it's a naked number and it's a constant. This 5 is just a constant. So let's go back and look at the rule for constant. This first one is zero rule. The second one is the constant rule. It says the integral of a number is just that number x plus c. Or if you look at this formula, it says the integral of a number is that number x plus c. So our answer is going to be 5x plus c. And then you can check yourself in your brain. What's the derivative of 5x? Oh, it's just 5. What's the derivative of a c constant? It goes away. So that's where there's no c in the original integral. Okay, let's look at part B. Part B, since there's a number in front of the x, and since we have an x, I'm going to use the power rule. So because I have an x, I'm going to use the power rule. On part A, I did not have an x on that 5, so I used the constant rule. Okay, so the power rule says the integral of something is, if there's a number in front, you write the number down in front again. So I have a number in front, 4, so I'm going to write that down in front again, 4. So that's the hashtag, the pound sign. Then I'm going to have a fraction, so I put a fraction bar. Then it says n plus 1 in the air. That's whatever exponent is on this x, I add 1 to it. So what's the exponent on this x? It's a pretend 1. So I'm going to write in my answer x to the n plus 1. X to the n plus 1. And my n is 1. So 1 plus 1. All over n plus 1. Oh, that's that same 1 plus 1 again. Okay, so let's see what this is. This makes 4x to the 1 plus 1 squared. All over 1 plus 1. 2. Good. And then, don't forget that plus c. Okay, the last step is to try and clean this up. I think 4 divided by 2 is just 2. So 2x squared plus c. And then to check yourself, go backwards. Bring the 2 exponent down in front. Multiply. 4. Check mark. Subtract 1 from your exponent. 2 minus 1 is 1. Check mark. We did it right. Okay, let's go to part C. Same thing. It's going to be equal to. I have a number sitting at the front, so it's going to stay sitting at the front. Then I have x to the n plus 1, as in exponent plus 1. So 3 plus 1, all over that n plus 1, which is 3 plus 1. Okay, then let's math. We get 4x to the 4, all over 3 plus 1. 4. And then a big fat plus c. And then let's do this. 4 divided by 4 goes away. So you just get x to the 4 plus c. Okay, if you want to check yourself, go backwards. Bring down the 4 in front, subtract 1 from the exponent, and you get 4x to the 3. Huzzah, we did it. Okay, let's go to part D. It says integral x to the 9. Okay, so I'm going to say there's no number in front, so I don't need a number to hang out in front. So I'm just going to go straight to x to the exponent plus 1, all over that exponent plus 1. So we get x to the 10, all over 10. And poop, I forgot my plus c. Okay, if you want to go backwards, check yourself. If I take the derivative of this and bring down the 10 in front, it cancels with the 10 on the bottom. And then I subtract 1 from my exponent, and I get 9. Okay, again, these next ones, same thing. They're just a little funky. Okay, so there's no number in the front, so I'm not going to put in a number in the front of my fraction. Then I'm going to say x to the negative 12 add 1, all over negative 12 add 1. Okay, let's clean this up. This makes x to the negative 11, all over negative 11, and put a big fat plus c on it. Whoops. And then if you want to check yourself, take that exponent and take the derivative. The exponent comes down in front, and it cancels with the denominator. Then you subtract 1 from the exponent in the air, and you get negative 12. Okay, let's go to part F. there's a number in front, so we're going to put equals a number in front, 25. Then I'm going to take that exponent and add 1. Then I'm going to divide by that exponent, adding 1. Okay, then we get 25x to the something over something. And if you want to do this in your calculator, that's cool. I'm going to put 3 over 2 in parentheses and then plus 1. And press math, enter, enter. And I get 5 over dose. Then I'm supposed to divide by whatever 3 over 2 plus 1 was. Well, it's 5 over dose. Okay, then we're going to clean it up. Just like on part B, we said 4 divided by 2 is 2. We're going to do the same thing here. We're going to say 25 divided by this fraction. I'm just going to use parentheses when I say divided by that fraction because I'm scared. So make sure you put parentheses in the bottom of your fraction. Yeah, okay. Anyway, hey, we get 10. How lucky are we? So we get 10 x to the 5 over dose. No more fraction. So when I did this 25 divided by 5 over 2, it gave me 10. And no more fraction in the front. And then don't forget, plus C. All right, again, the next one looks like a trick, but the only thing we know how to do is this power rule. So I'm just gonna go ahead and distribute this, and then it'll turn into something I can do. So this turns into the integral of 16x minus 2x squared dx. And then we're going to find the integral piece by piece. So first, let's do this 16x. Okay, 16x, that means there's a number hanging out in front. So I'm going to put a 16 hanging out in front. Then I'm going to add 1 to the exponent. And there's already my good friend Juan in that exponent. So my good friend Juan plus the 1 from the formula all over my exponent plus 1. Okay, let's see what this gives me. This gives me 16x to the squared over 2. Now let's work on this second piece. Okay, let's see here. I have a negative 2 attached. Poop. So I'm going to put a big fat minus because of the negative. And then my fraction, I'm going to start it with a 2. So the minus went to in between the fractions, and then the 2 went on the top left. Okay, then we're going to say x to the exponent plus 1 all over the exponent plus 1. And then let's see what this gives me. This makes minus 2x to the 3 over 3. And then the only thing we're going to do is maybe clean up this 6 to make a big fat, clean up this 16 over 2 to make a big fat 8. And then maybe put a plus C on the back end. And you just have to put plus C once, not twice. So let's see here. My final answer is going to be 16 divided by 2. 8 x squared minus 2x3 over 3. And then a big fat plus C. Hey, baby, done with that one. Okay, another. Let's say we have square root. Well, this is where our old math comes in that we've been doing from the very beginning. First of all, square root means 1/2 exponent. Secondly, something in the denominator means you pull it up, big and normal, and use a negative exponent. So let's look at our goodies. First, we have something in the denominator, so he's going to get pulled up, big and normal, with a negative exponent. Second, square root means 1/2. So my exponent is now -1/2. So this is the same thing as integral 9x to the -1/2 dx. Okay, and then now we can use our rule. There's a 9 hanging out at front, so I'm going to put my 9 hanging out in front. Then we're going to say x to the exponent plus 1 all over that exponent plus 1. Now I'm going to do that exponent plus 1 in my calculator, as in parentheses -1/2 plus 1, math enter, and I get 1/2. So this is 9x to the 1/2 all over, let's see, what was -1/2 plus 1? Well, it was whatever we got from the top, 1/2. Okay, then our final step is to divide these, and I'm gonna put in the bottom in parentheses because it's a fraction and I'm scared. So I'm gonna do 9 divided by parentheses, 1 divided by 2, close parentheses, and I get 18. So this is gonna be 18x to the 1/2, and then big fat plus C. Hey, nice.